Coach Foster here with you today because we've only got a few weeks left in the season, and we got to whip you guys into shape. So we've got plays to go over here, very important, and lots of work to do. So without further ado, let's get started. Hello. Well, yesterday was Charge, which was the intro to electricity, and really now today we get started on electricity. Really, it's the start. This is what launches us in to the next unit. And Charge was like the intro to this, and this is like the intro to everything else. So this is really what will help us. This is like the basics of circuitry and electricity, with our main topics really being current and voltage, and really also a third thing I guess is how a really useful way that we'll talk about electricity and stuff. So the first one, we'll start with current. So current is simply we think of electrical current. That's something you think of in everyday life, like electricity coming out of outlets and all that, powering things, traveling in power lines and all of that. So what's actually happening? Well, current is just like the flow of charge from one place to another. Specifically, the flow of electrons from one place to another, because protons don't really move as easily as electrons. So basically, in a power line, you've got a long string, right? And you just got electrons that are jumping down the atoms and traveling along the place. At least, generally speaking, that's not 100% how that works, but that's generally the idea. That electricity and current is just the flow of electrons. So whenever that's a pretty basic idea. Current is measured in amps, is maybe a word you might have heard before, AMPS, represented by a capital letter A, and it has a variable that we'll see in the future. We won't do anything with it today, but we will in the next lesson. The variable for current is a capital I. Capital I variable measured in amps, represented by an A, a capital A. So when we're talking about electricity, it's a flow of electrons, right, like I said. And so a really helpful visual and analogy for thinking about current, or thinking about electricity and how it works, is actually using water. And I'll talk about that as we get into each case. But for current, the way that you can think about how current and water go together, current is just the flow of water. That's pretty easy, right? Imagine a river, and your individual water molecules are going down the river, right? So they're flowing, much like current, electrons flowing from one place to another. So current, the similar word in river terms for that, right? You come like the current is pulling waves in and out, right? But yeah, so current is the flow of water from one place to another. Now, our next topic, this will be helpful here. Our next one is, before we get into stuff, is voltage. Voltage may be also a thing you've heard before. Batteries, right? You have them 9-volt battery, maybe, or less common nowadays, but maybe you've heard of one or seen one. But yeah, voltage has to do with electricity. Voltage is defined as the electrical potential difference between 2 points. And that sounds kind of confusing, but allow me to draw our analogy to water real quick. So you notice there's electrical potential. And I didn't say energy. It technically is electrical potential energy. And we've talked about potential energy before, right? It's stored energy. And so our analogous situation to voltage is a waterfall, right? So on a waterfall, you have one end that's high up in the air and one end on the ground, right? And the water, gravity naturally pulls the water down towards the earth. Right up here, we have lots of potential energy right up off the ground, and then the water falls to the lower energy place, right? Because you have less energy down here, less potential energy. And electricity works exactly the same way. So in that battery, where you've got a positive end, right, and a negative end on a battery marked with a plus and a minus. So on the minus end, you've got lots of extra electrons, and on the plus end, you have less. So you have a high concentration of negative charge here and a high concentration of positive charge. And you've learned this topic in chemistry before, is that things want to find an equilibrium, right? You want to balance out. You don't want to have lots of extra things in one place to another. So your electrons are naturally going to, if you give them the opportunity to, if you connect it up into a circuit, which we'll be looking at in a second, with a wire, and connect one end of the battery to the other, the electrons will naturally want to move from that high concentration, that high energy spot, through the wire to the lower energy, the lower concentration spot. Right? That's what causes current. So current is the moving of water. Voltage is the waterfall. And so notice that when we have a gap like that, right, the difference in potential energy here causes the water to flow from up here to down here, right? And it works the same in batteries. That potential difference, that electrical potential difference, the voltage difference between the two ends, is what causes electricity to flow through a circuit, because we've got lots of negatives here and lots of positives here, so the circuit's trying to balance out. The electrons are moving to balance out. And that's exactly how a circuit works. So to voltage, before we get on to circuits a little bit more, voltage specifically, it's represented by, this is going to be actually kind of easy. Voltage is measured in volts, complicated, represented by a capital letter V, and in the formula, its variable is also a V. So voltage, the variable's a V, the unit's volts, represented by a V. It's just all V. Pretty straightforward for that one. So what I wanted to get into now is how we're representing circuits, because current and voltage are two big ideas that we wanted to nail home, but we'll be using circuits throughout the rest of the unit here. And so there's many different ways. There's really what we want to be able to do is to communicate in circuit language. So you'll be seeing, we'll really go into how to diagram circuits in the future, but this generally is how we'll be showing them. They'll look kind of like this. You see I've got a battery here. It's got a plus and a minus side. The battery symbols will look a little bit different, but I just wanted to put this here for simplicity's sake. And then you're connected by the wire right there. That's what's going on here. And so this is what you'll see, or something similar to this is what you'll see when we're messing with circuits. But now that we've got this up, I wanted to talk about the flow of electrons, the current, because there's something important here. There's a little bit of a difference that I wanted to talk about. So in this setup, which way are electrons going to be flowing? Yeah, so they're going to be flowing from the negative to the positive, right? They're going to be flowing clockwise in this case about the path here, right, from the negative end to the positive end. And so it's right. The negative end has lots of electrons. The positive end doesn't. So it makes sense. They're going from high to low. They're going from the negative to the positive end. But there's a little bit of a confusing difference here, actually, in that there's a conventional way that we treat electricity to be flowing whenever we're making diagrams, and it's actually the other way around. So although electrons are actually flowing from negative to positive, the way that we treat electricity to be flowing whenever we're looking at things is actually from the positive end to the negative end. So it's technically the opposite way. It's called the conventional flow or something like that. I don't know why we do that. It's just kind of been the standard. So be sure to know that electrons are obviously going from the negative end where they are to the positive end, but that we treat electricity to be flowing from positive to negative. And that's really is what is going to launch us into the rest of our stuff next week, or well, next lesson. Depends on when you watch this, I guess. Next lesson, we're going to get into a little bit more of the specifics on circuits and get into how we're using them and what to do with them. So that's really all that I wanted to talk about for this one, is to introduce the idea of the water analogy, and then also talk about circuit diagrams and flow. So be on the lookout for more circuit diagrams. Some people really like circuit diagrams. Maybe you'll find yourself liking circuit diagrams. But for now, that's all. Be sure to hit up the exit ticket. I feel like my hit the exit ticket up is like your like and subscribe sort of thing. It's becoming that, at least. Oh well. I am what I am. Bye.